Welcome to the Approach to ABGs Part 3, Shifting Chemistry. Shifting chemistry explains why the hydrogen ion concentration goes up or goes down. I'm going to bring you back to high school chemistry where you may or may not have learned about something called Le Chatelier's principle. And this basically says that if you have four chemicals in solution, A plus B on one side of the equation, C plus D on the other side of the equation, they are always in balance with each other. If one side goes up, it's going to have an impact on the other side and vice versa. And specifically, we're going to look at a few very important examples. Let's start off with the example where one chemical goes up. So let's say we add chemical B to this solution. We add some extra chemical B so that the concentration of chemical B goes up. This is going to shift the equation, the chemistry, over to the right side because now we have more chemicals on the left-hand side. We have more of B, and they are going to react with each other, and they're going to create new or extra chemicals C and D. So if you add chemical B, it's going to react with chemical A, and it's going to create more of C and D. This is going to consume chemical A. So if we add chemical B, chemical A goes down while chemicals C and D both go up. So this equation shifted from the left side, the A and B, it shifted over to the right side to create additional C and D chemicals. What if we were to magically reduce a chemical? Let's say that chemical B, the concentration goes down. This is going to act like a little bit of a vacuum on the left side of the equation. And the equation is going to shift to the left. This is going to consume chemicals C and D, so their concentrations are going to go down. But when C and D react together, they're going to create more of A and B. And so chemical A is going to go up. So to reiterate, if the first event is that chemical B goes down, the second event is that chemicals C and D will react with each other and their concentrations will go down and chemical A will go up. The same philosophy or principle is true if we manipulate the right side of the equation as well. If we change the values or the concentrations of chemicals C and D, it's also going to make some changes in the equation. So if we made chemical D go down, that's going to create a little bit of a vacuum on the right-hand side of the equation. The equation will shift to the right. Chemicals A and B will be consumed in the process, so they will be reduced. But this will generate more chemical C. And if we increased chemical C, this is going to shift the equation to the left. Chemicals C and D are going to react with each other and produce more of A and B, but chemical D will be consumed in this process and its concentration will go down. So these are essentially the components or the concept of shifting chemistry. And let's see if we can apply this now to our acid-base chemical solution. So remember, water, H2O, breaks down into hydrogen ions and hydroxyl ions. And we're going to just turn this around so that the hydrogen and the hydroxyl are now on the left-hand side of the equation and the oxygen is on the right. And now we're going to add carbon dioxide. And this is the only change we're ever going to make to this equation. So it's not going to get any more complicated than this. If we add carbon dioxide, we're going to add it to both sides of the equation. And on the left side of the equation, the carbon dioxide is going to join with the hydroxyl chemical, and it's going to turn into HCO3 with a minus charge, and we're going to call this bicarbonate. So on the left-hand side, we have the hydrogen and the bicarb, or bicarbonate, I'll just call it bicarb. And on the right-hand side of the equation, we have the water and the carbon dioxide. Now, we're talking about blood, and blood is mostly water, and it doesn't really make sense to talk about water dissolved in water. And so we're just going to make our lives easier, and we're going to make that water molecule disappear because we can actually completely ignore it. So we're going to drop that water molecule out, and this is our most important equation. And what we're going to do is we're going to use this equation, and we're going to apply the principles of shifting chemistry, left or right, and we're going to ask the question, when something happens, what is the result of the hydrogen ion concentration? Because remember, the hydrogen ion concentration dictates how much acid or base you have. So this is the most important equation in acid-base interpretation, or ABG, arterial blood gas interpretation. And I want you to memorize this equation because it's very important. You are only going to ask 2 questions with this equation. The first question you're going to ask is, if the bicarb goes up or down, what happens to the hydrogen ion concentration? And the second question you're going to ask is, if the carbon dioxide goes up or down, what happens to the hydrogen ion concentration? Trust me, make your life easier. There are actually only 4 scenarios you really need to understand, but you need to understand them standing on your head and in your sleep. So we're going to go through these in very careful detail. So your question number 1, if the bicarb goes up, what happens to the hydrogen ion concentration? And if it goes down, what happens to the hydrogen ion concentration? And then the other 2 questions, if the carbon dioxide goes up or the carbon dioxide goes down, what happens to the hydrogen ion concentration? So let's calculate these and see what would happen. Before we do, though, you're going to be tempted to ask additional questions, but don't do this. Do not ask the question, if the bicarb goes up or down, what happens to the carbon dioxide? Don't go there. We will address this later, but for now, you're just going to confuse yourself and mess everything up, so don't do that. And when you're looking at the carbon dioxide, watching it go up and down, do not ask what happens to the bicarb. This will only make you confused, and we will deal with this later. So let's practice. This is scenario number 1, and we're going to say the bicarb goes up. So when the bicarb goes up, the question that you're asking is, what happens to the hydrogen ion concentration? You are not asking what happens to the carbon dioxide. So if the bicarb goes up, according to the shifting chemistry we talked about, that's going to push the equation to the opposite direction. So it's going to shift right. When this equation shifts right, the bicarb and the hydrogen ion concentrations are going to react with each other. This is going to consume the hydrogen ions, and therefore the hydrogen ion concentration will go down. So when the bicarb goes up, the hydrogen ion concentration goes down. Scenario number 2, when the bicarb goes down, what happens to the hydrogen ion concentration? Well, the bicarb goes down, it's going to create a little bit of a vacuum on the left side of the equation. So it's going to shift left. When it shifts left, the hydrogen ion concentration is going to go up. So when bicarb goes down, the hydrogen ion concentration goes up. Scenario number 3. What happens when carbon dioxide goes down? This is going to create a little bit of a vacuum on the right-hand side of the equation. So the chemistry is going to shift to the right. And remember, we're ignoring what happens to the bicarb. When the equation shifts to the right, the hydrogen ion concentration is going to get consumed and it's going to go down. So when carbon dioxide goes down, hydrogen ion concentration also goes down. And the opposite, what happens when carbon dioxide levels go up? We're asking the question, what happens to the hydrogen ion concentration? We're not asking what happens to the bicarb. So carbon dioxide goes up, it's going to shift the equation over to the left. This is going to generate more hydrogen ions. And so when carbon dioxide goes up, hydrogen ion concentration also goes up. This is the most important acid-base foundation, is understanding how these chemical equations shift to the left or shift to the right. And I would encourage you to rewatch this video as many times as you need to learn these concepts 100%, because everything we're going to do in future podcasts builds on this topic. If you are a little bit confused about shifting left, shifting right, what happens to the hydrogen ion concentration, you need to rewatch this video until it's fully understood. And if you're not totally comfortable with this topic, you will be confused in the future topics.